Hello, in this video we'll cover the concepts from Chapter 3, Business Intelligence and Data Warehousing. So, business intelligence used to be everything related to the use of data for managerial decision support. Now, we consider it part of business analytics and use it to refer to mostly descriptive analytics. And in this picture, you can see that data warehousing is under descriptive analytics right here. BI systems mostly rely on data warehouse or data marts as the information source for creating insight and supporting managerial decisions. A variety of organizational and external data needs to be captured, transformed, and stored in data warehouse or data marts to support timely and accurate decisions through enriched business insights, which the users can access through a variety of applications. So let's discuss what is a data warehouse. The data warehouse is a collection of integrated subject-oriented databases designed to support decision support systems where each unit of the data is non-volatile and relevant to some moment in time. And we'll discuss each one of these characteristics. What is important for us to understand is that data warehouse is a physical repository where relational data are specially organized to provide enterprise-wide cleansed data in a standardized format. And usually when we do this, we add timestamps to it so we know this piece of data belongs to what time. Now let's go to the characteristics of data warehouse, some of which we saw in the previous slide. Subject-oriented, what does that mean? It means that the data is organized around a central focus or theme, such as maybe just sales data or data for products or customers, etc. This will help in decision making. So a data warehouse doesn't have to be all over the place or mixed bag. It has to be subject oriented. Integrated means that data from different sources are organized in a consistent format. Time variant characteristic indicates that historical figures are kept to track changes or trends in data. So if you are tracking, let's say, sales data, you will have sales data over time so you can see if there is a trend or a pattern. Non-volatile characteristic indicates that once the data is in the data warehouse, it is not going to change. Summarized characteristic indicates that the data can be consolidated to a singular granularity. And non-normalized indicates that unlike databases, we don't have to worry about putting the data in a third normal form, which is what we commonly do with databases. And metadata is information about the data it contains. So the data warehouses also store metadata. So what data is stored, what does it indicate? So all metadata will be stored in the data warehouse as well. Here's a historical perspective for data warehousing. You may think that this is a new term. However, the concepts that go behind the development of data warehouse or the motivation dates back to as early as 1970s, starting with storing data on the mainframes. In 1970s, late 1970s, Teradata was a company which came into being. It grew out of some research at Caltech. And this was one of the primary companies providing data management solutions. In 1980s, there were a lot of personal computers and mini computers being used, which led to everybody creating their own little stores of data. We can name it an island of data. And the problem came that how do you integrate all of these data to make some enterprise-wide decisions? One of the solutions came out as something called as distributed DBMS or distributed database management system. What it would do is pull the requested data from multiple databases across the organizations and use it to conduct the analysis. Most initial solutions on this line didn't work, but then Teradata had a solution which kind of seemed to work at a commercial level. Teradata is still one of the biggest companies that works in data warehousing space. And this was the period, so 1980s was the periods when the term business data warehouse was coined. Come 1990s, a new approach to solving the island of data problem was developed. Instead of accessing the data directly from the files and databases for analysis, all of this data from these different places were now copied to one central location, and hence a centralized data storage termed as data warehousing was born. So some popular books from this time can be one by Inman called as Building the Data Warehouse, another by Kimball called as the Data Warehouse Toolkit. These were some of the few books of that era which give a lot of information about the architecture and design of database. Then in 2000s, different vendors came up with their own enterprise-wide data warehouse solutions, and a lot of different new technologies which were working on data warehouses were being developed. Since 2010s, the big buzz has been big data. And right now, a lot of different kind of analytics like social media analytics, big data analytics, text and web analytics are being conducted. And if you think about both of these technologies together, like big data technology, which came with different algorithms to tackle it, such as Hadoop, MapReduce, NoSQL, Hive, combining with data warehouse, a lot of different developments have happened, but things are still evolving. So that was data warehouse. What's a data mart? A data mart is a data warehouse that is limited in scope, customized for decision-making applications, or a particular end user group. We can think of it as a subset of a data warehouse, typically consisting of a single subject area or topic. Like this is just the data mart for marketing or just for operations, like that. A data mart can be either dependent or independent. What that means is a dependent data mart is a subset that is created directly from the data warehouse. For this, you have to build the data warehouse first. It has the advantage of using a consistent data model and providing good quality data. An independent data mart is a small warehouse designed for a strategic business unit or a department, but the main difference is that its source is not an enterprise data warehouse. So the data is not coming from the data warehouse. Let's look at some of the other data warehouse components, such as operational data stores, which is a type of database often used as an interim area for a data warehouse. Typically, we use these for customer data that is updated over short periods. Another variation is an Oper data marts or an operational data mart. These are typically derived from the operational data stores, and it allows for operational data to be analyzed multidimensionally. Enterprise data warehouse is a data warehouse for the entire enterprise, and it serves as a single source of data for the organization at large. Also, in your data warehouse, you would be storing metadata, which is data about the data. We know that data warehouses are costly to build and it takes a lot of effort as well. So we need to justify why we need those. Here's an example of some of the benefits that were noticed in an automotive industry application, such as reduced infrastructure expenses or product warranty expenses were reduced, cost of quality was improved. It led to IT architecture standardization because you now need to get data from multiple sources and put it in the data warehouse. So a lot of standardized practices were being followed, things of that nature. And this may depend from industry to industry, but there is definitely some benefit in having some data analytics in place.